Okay. All right, so we're on a base to final for runway 17 left. I can see 17L painted on the runway, so that's it. The procedure for landing is exactly the same as the Cessna, the same speeds and same flap settings. These old Cessnas have a 40-degree flap setting we don't really use much. It's a heck of a lot of a drag. I'm in the white, flaps are 10. Usually about 1600, 1800 RPM. Works pretty good.
Right, heading 080.
For our final approach.
Fast track 34. Experimental 2 Charlie X-ray, is this a touch and go or a full stop?
We're requesting the option, but I'll tell you what, we'll do a go around at low approach 17 left or make left traffic.
Experimental 2 Charlie X-ray, runway 17 left, clear for the option.
Clear for the option, runway 17 left, and 2 Charlie X-ray. Okay, so we're just coming up on final now for 17L. I usually like to stay a little high and a little hot on a single engine piston. I try to commit to landing when I can make it. I can glide to the runway in case we lost the
Rally 705 mile final.
So wind's a little bit goofy up here. It's bouncing around.
70 Springs Tower.
Probably plus or minus 10 knots. There's a good one right there. Our before landing checklist is pretty easy because we don't have a carburetor heat or mixture control. So before landing checklist is gas is on both, just like the standard 172 it is. Landing lights on, it is on, and seatbelts are secure. They are secure. Let's go flaps 20.
17 right, citation.
And where you really see the power of this V8 is on the go around. And let's go flaps 30. I'm going to commit to this landing. Landing checklist is complete. We're in our final configuration, and I'm about on speed, so I'm stable. Continuing. This is almost a 500 horsepower engine, and it's derated at 210, but man, it gets there pretty quick. So here we go. Here's our go around. Max power. Flaps 20. Notice we're accelerating. This aircraft's already at 70 knots, and we still have flaps at 20. And we're at a density altitude of 7,400 feet. Lots of power coming up. And we're already above VY. A little bit slow on the yoke. And we're climbing out. Let's see what we do with our climb out here. It's really bouncy up here.
Experimental 2 Charlie X-ray, left close traffic approved. Plan to follow Boeing 737 traffic on the 8-mile final.
70 Charlie X-ray will do. All right, so flying real nice. There's our VY speed, so looks like about 800 feet per minute. We're about 2,450 pounds right now, which is pretty good for a beat-up old 172. It's a 50-year-old airframe, and it's beat up. 8,000-foot density altitude. What we could do is go to about 2,800 RPM. That's going to give us about 160 horsepower, which is about the same as what you're going to see in a 180 horsepower stock Cessna at this density altitude. And you're going to notice that we lose almost half our climb rate. We'll probably expect to see about 350 feet per minute, typically at 160, 170 horsepower. So there's, let's see if I can get 2,800. There's 2,800. That's my tachometer. That's my engine temperature. This is fuel flow, and this is our fuel pressure.
Final and over the runway.
So there's VY, somewhat trimmed, bouncing around a little bit. And looks like about 350 feet a minute, which is what we expect. And coming up on traffic pattern altitude, so we'll bring the power back a little bit. About 2,500 RPM works. And we're clear left. Our after takeoff checklist is pretty simple. It's flaps up and off. These old Cessnas have an off position at the top. And engine checks. Again, there's no engine lights illuminated, and there's no faults that are being displayed on the SED. So it really relieves the pilot of a lot of that workload of monitoring. Here comes our downwind, clear left. And so 2,500 RPM-ish works pretty good on the downwind. It keeps us in the white arc for flap extension. And brings our fuel flow back considerably as well. All right, so we're on the downwind. Our before landing checklist is gas is on bolt, just like the stock 172. Landing lights on, it is on, and seatbelts are secured, they are secured. So we're established on the downwind here. We're going to
2 Charlie X-ray, follow Boeing 737 traffic on 2 mile final, caution Lake City.
and visual contact, and we'll reference that traffic. Clear for the option runway 317 left, 2 Charlie X-ray. All right, so we're established on the downwind. Got about 2,500 pounds. We're burning just about 5.5 gallons an hour. Getting bounced around a little bit. We have a density altitude here of about 8,300 feet. And we're doing about, what's that say, 99 knots true airspeed. So not too bad. Be a lot better if it wasn't so bumpy. But what I wanted to show now is the backup system. The ECM system has 2 systems. There's a main system and a backup or the auxiliary system. Both of them are completely redundant of one another. They both have their own battery, their own engine control module, their own sensors, their own fuel filter, fuel pump, and fuel pressure regulator, among other things. And they're completely isolated from one another. The aux ECM system is completely isolated from all the other systems. Its battery only powers it, the aux system, and it's there to keep the engine running. So we're going to go ahead and fail the engine, and when the engine fails, we'll let the windmill, the prop windmill for a little bit, and then we'll go ahead and just flip it to the aux position, and you'll see within about a half a second the engine is restored. So here comes engine failure in 3, 2, 1. There it is. So we're just windmilling right now. So you see that we're going to lose all our SED here in a little bit. We've lost the engine. The engine's dead. So what we're going to do is just click to the aux position, and the engine comes right back. It's going to come back within about a half a second. This is what a fault will look like. It's an amber one. This is telling us that we have a low oil quantity, and that's an induced fault for display purposes. And we see that the aux lamp is now turned on, letting us know that the aux fuel pump is being commanded on. We're in the white arc. Here comes flaps 10. And if you got this in flight, an amber is just more of an advisory and cautionary. So we're going to go ahead and cancel that out. There's a little bell here. If we push that, it'll get rid of the beeping and the flashing, and it'll store all that information in the maintenance page, which includes not only the description of the fault, but also
runway 13 arrival on departure, wind shear alert 20.
The specific fault code
to the runway,
and a timestamp. And we can look at that on the maintenance page after we land.
10.16.
We got low-level wind shear alerts going on. I'm pretty happy where I am. I'm in the white. Here comes flaps 20. Oh, really bouncing around now. And there's 17 left. That's our runway. So our before landing checklist is complete. Oh, bouncing around. Okay, so again, standard procedures for the 172. I'm pretty happy where I am. I can make the runway. Here comes flaps 30. I'm going to commit to it. And we're going to do another go around out of here. And I really want you to watch how smooth this thing transitions and accelerates, even with the flaps still in the down position. And let's see, we're going to do a go around once we start about 5 feet off the ground here. And go around. Max power, flaps 20. Look at this thing climb. And we're stable and accelerating. There's VY. And we're right at VY now. We're now clean. And we're going to probably cross the end of this runway about 900 feet above the runway.
Terminal 2 Charlie X-ray, did you get any wind shear?
Just about 5 knots, nothing too bad.
Terminal 2 Charlie X-ray, roger.
So we're going to have a little crab into the wind here, but again, we're going through 7,700 density altitude, which is the air's pretty thin up here. We're climbing about what's that? About 800, 900 feet a minute at max power, and we have mostly a crosswind component right now. And again, the engine is controlled by software, so the engine control modules are controlled by software, and we program what the torque and the power settings, max powers are for the engine to put out. Right now, they're programmed for about 210 horsepower. So that's what we're seeing about 3,000 RPM is just about 205, 210 horsepower. going to bounce around here a little bit, but where there's an updraft, there's a downdraft. So right now we're just about 1,000 feet above the ground. We're not even at the end of the runway. Let's see if I can see. Yeah, we're at the end of the runway now, so we're 1,000 feet above the runway at the end of the runway. And that performance is pretty cool, but what it does is it buys you a lot of safety margin in case you did have an engine failure on takeoff. Most of those turns back to the runway after a engine failure don't end very well. It's often called the impossible turn. Clear left. After takeoff checklist, his flaps are up and off. They are. Engine check. Engine checks good. Notice we're still on the auxiliary system. So we did a whole go around on the aux system. The aux system is pretty much a mirror of the main system. There's a couple less bells and whistles, but the aux system is completely isolated. It's there to keep the engine running with its own battery, and it can also take alternator power and also take power from the main battery as well if needed. It's pretty smart. The engine instruments are all powered by an auto transfer bus, so if you did lose power on one system, these would automatically swap to the operating powered system without doing anything. So we can switch back to main now. All we got to do is just turn the key. You're going to notice the engine dies for just a brief second. That's because when we swap from one system to the other, the systems isolate themselves, so we don't have a fault in one system contaminating the other.
Wind 09016.
Clip of the option, 17 left, 72 Charlie.
Number 72 Charlie X-ray. I'm still getting a wind shear alert for runway 13 departure and 20 knot gain over the runway. Wind 080 at 14 for runway 13.
Yeah, definitely be a low approach for us, then. Thank you.
Number 2 Charlie X-ray. Click for the option for runway 17 left.
Clip of the option, 17 left, 72 Charlie X-ray. So when we swap over, you're going to notice the engine dies for just a brief second as those systems become isolated. So let's go back to main. Here it comes. There's the dead for just about a half a second, quarter of a second, and we're right back to operate. And we can go back and forth to aux to main without limitation. We try not to use the aux system too much. We try to keep its fuel filter as clean as we can so we can rely on it and not use the components too much, so the aux system lasts a lot longer and is more reliable for us. All right, so we got plus or minus 20 to 30 knots gain on over the runway, so we're going to do a low approach, maybe keep the speed up a little bit. We're in the white arc. Here comes flaps 10. And again, standard landing procedures with the aircraft. Let's see, finals clear. Here's our left turn. And there's 17L, that's our runway. Kind of on a short approach here, base. I like where I am. Here comes flaps 20 in the turn. Got about 75 knots at our target. Boy, look at that wind. All right, and let's go flaps 30 now. Pretty happy where we are. Start slowing down now. We're stable. And here comes our go-around. So again, standard go-around procedures. There's idle and max power. Flaps 20. And we're already about 100 feet above the ground here. And here's where that wind shear has been reported. And everything's pretty stable. VSI is increasing. I'm clean. What we can do now is we can bring this again back to 2800. Now look what happens here. We got at max power about 210 horsepower. We got about 11.5 gallons per hour. If we bring this back to about 2800 RPM, right about there, we go down to just shy of 8 gallons an hour. And again, this is about 160 to 170 horsepower, about what you'd have in a normal 172.
Alert 15 knot gain, 1 mile final, wind calm, possible wind shear outside of network.
There we go. So yeah, we're nice and stable. There we go. Just about 8 gallons an hour in our climb. And this thing's bouncing around because of the turbulence out here, but we're going to sacrifice a little bit in our climb rate, but we're saving a lot of fuel, and if you really don't need it after about 500 feet, you can power back and save some gas, depending on what your departure is. We're going through 8,000 feet density altitude. Air's very thin, especially for a single engine Cessna, and it's performing really well. And the after takeoff checklist is flaps up and off. They are. Engine checks. Again, if we had a problem, these lights would illuminate, or we'd see a flashing amber or red SE default. Yeah, we're a little bit past the end of the runway now. We're still about 200 feet below traffic pattern altitude, or about 800 feet above the ground. And we're going to make this one a full stop. And 72 Charlie X-ray is turning the downwind, and that'll do it for us, requesting a full stop for runway 17 right.
Number 72 Charlie X-ray, Tower Roger, enter left base, runway 17 right.
And what's the winds on 17 right?
Runway 17 right, arrival wind 090 at 12, and departure end wind 090 at 15. Airport wind showing 07013, gust 20, and I'm still showing wind shear 20 knot gain over runway 13.
All right, get a little bit of about a 12 to 14 knot crosswind component for our landing runway. So on the downwind,
what we need about 1 minute down there at the end.
what we do is about
753 spring salad or something.
again 25, 2600. Boy, we're getting the heck beat out of us up here. But the aircraft, as you can see, the aircraft flies really well. It's very responsive. Now, again, this is about a 500 horsepower rated engine. It's detuned or flat rated to just about 220 horsepower at its max. Right now, this is programmed, and which we do with software to the engine control modules. It's programmed for about 210, which is really a sweet spot for the airframe, we think. Over 210, you get a little bit climb rate, but you really don't get much more than a 3 to 5 knots in cruise, but you pay for it with gas. The airframe has a drag coefficient that's consistent regarding how big of an engine you put on it. Right now it's costing us about $19 an hour to fly this thing. We're using, oh look at that, we're using automotive gas, and over the last year we've been putting nothing but...
X-ray change to runway 17 right, runway 17 right, clear to land, wind 080 at 13, gust 20.
17 right, clear to land, sir, control action. Over the last year, we've used nothing but 85 octane ethanol car gas, which is about the lowest octane we can find, and 10% ethanol. And we've had no problems. The spark plugs are all running really well, clean. Our oil analysis shows that we can go over 100 hours before we need an oil change, and we don't need an engine run-up. If you're not burning AVGAS, we can go right by the run-up area, and we can do our two engine checks on the taxi, which saves a lot of time, and time is money. Also, we're not producing leaded gas emissions, which is awesome for the environment as well, which was one of our targets and missions that we had when we went into the design. Okay, there's we're getting bounced around up here.
Land 777.
And here comes our base turn for us, clear left. Before landing checklist, is gas is on bolt, it is bolt. Landing light is on, it is on, and seatbelts are secure, they are on before landing checklist is complete. And this is an old airplane. This is a beat-up 1969. It makes a great test bed for us. But when you see this airframe, you'll see Bondo on it and patches. It's been beat up pretty good, and it flies really well with this engine. We can outperform any other Cessna model, including the brand new S models or the XP model. Okay, I'm in the white arc. Here comes flaps 10. Start looking for about 80, 85 knots. And again, down here, we're going to have about a 12-knot crosswind component. But putting that automotive gas in is really neat. It really has so many benefits to it. Here comes flaps 20 in the base to final turn. And because of this crosswind, I think I'm going to land with flaps 20 and about 70 knots on
100 at 16
on the speedometer.
Southwest 753, contact departure.
Switch departure, Southwest 753.
Oh, look at that one.
Central aircraft runway 13,
Okay.
arrival wind shear alert 20, knot gain 1 mile, final wind 100 at 16, possible wind shear outside the network.
All right, 17 right, that's our runway. I'm going to stay a little bit high and hot here. I'm going to slip it just a little and get rid of some of this speed. Whoa, look at that. And I can feel that crosswind coming in. Oh, look at that.
Tower, wind shear alert was on one way.
Runway 13.
We'll get it down here eventually. There it is. There it is. That was a challenge.
Charlie X-ray, no delay, right turn Alpha 3, please. Got a line waiting to go.
Okay, we'll catch the next one, and be advised about a 15 knot on very short final line.